So here we have a slightly more complicated case. Again, it's improper integral. So t is approaching minus infinity. So t to 0. So we gotta figure that out first. What's the technique that we need to use to integrate this?
Integration by parts.
That's right, integration by parts. So let u equal to x, dv equal to e to the power of x dx, du becomes dx, and v becomes e to the power of x. So this whole thing becomes x e to the power of x, right, minus e to the power of x integral. But I'm going to remove the integral right away because we know the integral of e to the power of x is e to the power of x. So we have 0 and t. So plug in 0 and we get minus 1. And minus plug in t e to the power of t minus e to the power of t. Don't forget this bracket, this inside bracket. A lot of students are too lazy with the bracket and they get the entire question wrong. Negative 1, negative t e to the power of t plus e to the power of t. So yes, I've got the negative infinity at the front. Now I have it. So the minus 1 can be left out at the front. Okay. And we have to take care of these two limits. With the way it is, it's hard to make sense out of minus infinity times e to the power of negative infinity. So to make it more plainly obvious, let's just introduce a new variable. Let me let u equal to minus t, okay? Okay. So as t approaches minus infinity, you can see that u will approach positive infinity, right? Okay, but we get the following: minus u e to the power of minus u. And e to the power of minus u. Now it's going to make more sense. So you get u e to the power of u one over e to the power of u. Okay, this one here is clearly approaching 0, right? This one here, you have to use L'Hopital's rule, right? Because it's an infinity over infinity case. Remember, infinity over infinity, we can use L'Hopital's rule. And you get this if you do that. Just differentiate top and bottom separately. You can see you get another 0. So the whole thing is approaching 1. So this is a typical, semi-challenging question, right? We have to do integral. After we're done with the integral, we're doing limit, which involves derivatives as well as L'Hopital's rule. So we're actually intermixing the second part of calculus 2 and calculus 1 here, right?